Welcome back. In this session, we try to derive the coefficients alpha and beta based on minimizing the sum of squared residuals. We start with a very simple model where we only have one variable, xi, that explains our dependent variable yi. Note that we have a sample running from 1 to capital N. So I is 1, 2, and so on, going all the way up to capital N. In the previous session, we derived the sum of squared residuals by rearranging this equation as follows. So here we have the sum of squared residuals, which is the sum starting from I is equal to 1, going all the way up to capital N, and then the squared residuals, which refers to the observed yi minus the predicted value. The predicted value refers to the constant term alpha, and we have to account for the slope coefficient beta and the value of xi. Note that we replaced the alpha and the beta with their point estimates indicated by the alpha hat and beta hat. And now our objective is to minimize the sum of squared residuals by selecting an optimal value for the alpha hat and beta hat. So we have two parameters to determine. Let's start with the constant term. So we basically derive a first order condition. So here I refer to a partial derivative because we have two parameters. And when I differentiate this expression, so the 2 can go front, we have a sum. So that's basically, of course, the chain rule. We reduce it by 1, the power, and then of course we differentiate inside, so we get a minus 1, and that's equal to 0. So that here is our first order condition. And of course you note that we could get rid of the 2 and the minus 1, and we can just put everything outside these brackets and apply the sum as follows. And we end up with the following condition. So we get the sum of yi minus the sum over all the alphas. Of course, it means we have n times alpha hat, and then minus beta hat. This can go outside the sum, and the sum up to n of xi equal to 0. Good, now we rearrange this and solve for the alpha hat. We just move it on the other side. We divide by the capital N, which is our sample size. So we should obtain alpha hat as equal to 1 divided by n, then the sum of yi minus beta hat, then 1 divided by n, and the sum over the xi. So that's quite a useful start. So I will just mark this for later use. And now we introduce the arithmetic mean. So what I mean by that, which is kind of funny, is the x upper bar is defined as 1 divided by n, the sum from 1 to capital N of xi. And of course the same applies to any other random variable. So that's basically our mean estimate. So that's the mean, and we now use it in our equation. Let's call this star. So from star we obtain then the following. The alpha hat is equal to y upper bar minus beta hat x upper bar. And this is pretty useful. So that would be our estimate for the constant term. Now, when we look back to our initial equation up here, we could now use our estimate and rewrite this equation, which is kind of interesting and will simplify our problem quite a bit. So we have yi is equal to, now we have the alpha, which I replace with my estimate, which is simply y upper bar minus beta hat x and upper bar, and then we have here the plus beta, which I now replace with beta hat, xi plus epsilon I. Now we just rearrange a little bit and we obtain yi minus y upper bar. So basically this refers to my dependent variable where I deduct the mean. So this is a standardized dependent variable which by construction has a mean equal to 0. And then I obtain here beta hat and then xi minus x upper bar plus epsilon I. So what I basically look at is I look at an adjustment or a standardization where I refer now to the y as y star I and the x would be xi star. So this is simply adjusted for the mean. We deduct the mean from these variables. And when you do this, as you can see, the constant terms simply drop. So this then simplifies to a problem where we just have one coefficient to determine, which is the beta hat. So you see, standardization can simplify our problem by eliminating the need for the constant term. In fact, in many machine learning applications, it is a default procedure. You always standardize your variables. I see you in the next session where we now derive beta hat.